Hello and welcome to EduSTEM. Today we will be studying GCSE Chemistry with molar concentration and volume. Before we begin, make sure you have your calculators and your workbook ready, as we are going to do some calculations related to concentration and conversion. This topic is very useful in terms of understanding how concentration is written in two different formats: grams per decimeter cube to moles per decimeter cube, and how is volume converted from centimeters cube to decimeter cube. So before we begin, what is concentration and what is volume? These two terms are often used with one another, especially with calculations related to titrations. However, there is a big difference between these two in terms of the way they're expressed and what do they mean. Now you have a 5 setup test tube in front of you, and as you go from A to E, there is an obvious variation in the color of the liquid. So which test tube represents liquid with most concentration and which test tube represents liquid with least concentration? If you had selected A for the most concentration and E for the least concentration, that's correct. As you can see that this test tube show the amount of solute per given space decreases as you go from A to E. So what exactly is concentration? Concentration refers to the amount of substance per defined space. Units for concentration is grams per decimeter cube or moles per decimeter cube. Volume refers to quantity of three-dimensional space occupied by a liquid, solid, or a gas. Units for volume is centimeter cube or decimeter cube. One of the apparatus that you can name is measuring cylinders and beakers, as well as volumetric flask. They are all have units of centimeter cube or decimeter cube. Chemist needs to communicate outcomes, and therefore they express concentration of the solution as the amount of substance dissolved in a certain volume of solution. So to express concentration in grams per decimeter cube, we use following formula, where mass in grams is divided by volume in decimeter cube. Now 1 decimeter cube is equal to 1000 centimeter cube. It is important is when we are dealing with concentration, our volume is given in decimeter cube. If a volume is given in centimeter cube, it must be converted to decimeter cube by dividing it by 1000. For example, 25 centimeter cube is divided by 1000, resulting in 0.025 decimeter cube. Let's look at a working example. You have 40 grams of potassium hydroxide dissolved in 750 centimeter cube. Write down concentration of the solution in grams per decimeter cube. So step 1, you convert the 750 centimeter cubes into decimeter cube, which results into 0.75 decimeter cube, followed by the formula produced is amount in grams divided by volume in decimeter cube, which gives you the concentration of 53.33 grams per decimeter cube. Let's have some practice ourselves. Express the following amounts in concentration with the units of grams per decimeter cube. There are 6 examples. Remember to convert centimeter cubes into decimeter cube if needed. The extension question is also placed in for you, where you have to rearrange the formula to find the mass of sodium bromide in 500 centimeter cube. So here are the answers. So 24, 35.7, 15.8, 9.4, 6.8, and 3.2 grams per decimeter cube for question 1 and 6. Well, question 1 to 6. The extension question requires you to rearrange the formula, where you convert the 500 centimeter cubes into decimeter cube, Hence, the answer is for the step 1 is 0.5, followed by mass equals to 0.5 times 150 grams per decimeter cube, which has already been provided in the question. So you end up with a mass of 75 grams. Why is concentration written as moles per decimeter cube? Concentration is expressed in terms of moles for volumetric calculations such as titrations. Concentration in grams per decimeter cube is converted into moles per decimeter cube. In order to do this, we must know the molar mass of given compound. For example, let's work out the concentration in moles per decimeter cube for potassium hydroxide, which has a concentration value of 15 grams per decimeter cube. Step 1. We must work out the molar mass of potassium hydroxide by adding the relative atomic masses, which works out to be 56.1 grams per mole. Step 2. We divide the grams per decimeter cube by the molar mass of potassium hydroxide, which works out to be 15 grams decimeter cube divided by 56.1 gives us 0.267 moles per decimeter cube. To summarize so far, centimeter cubes divided by 1000 gives us decimeter cube, and decimeter cube times by 1000 gives us centimeter cube. The similar pattern is applied when we convert grams per decimeter cube into moles per decimeter cube. We divide grams per decimeter cube by the molar mass of the given compound to produce moles per decimeter cube, and in order to produce grams per decimeter cube, we times the molar mass of the given compound by the mole per decimeter cube. Let's practice the conversion of grams per decimeter cube to moles per decimeter cube of the following compounds. Step 1 involves the calculation of molar mass of respective compounds, which are 40.1, 17, 60, 36.1, and 74.1. Step 2 involves the division of grams per decimeter cube value by the respective molar mass of the given compound. For number 1, it's 0.5985. For number 2, it's 2.1. For number 3 is 0.2633. For number 4 is 0.2604. For number 5 is 0.0918. If you got all of them correct, well done. To summarize, let's work out the following calculation. We have 28.6 grams of sulfuric acid dissolved in water, and the solution is made up to 500 centimeter cube. We have to calculate the concentration of the final solution in grams per decimeter cube as well as moles per decimeter cube. We have been given the relative atomic mass of hydrogen, sulfur, and oxygen. Step 1 involves conversion from 500 centimeter cube to 0.5 decimeter cube. Step 2, we have to calculate concentration in grams per decimeter cube by 28.6 grams divided by 0.5 decimeter cube, which gives us 57.2 grams per decimeter cube. Then we work out the molar mass of H2SO4, which gives us a total of 98 grams per mole. Finally, we work out the concentration in moles per decimeter cube by 57.2 grams per decimeter cube divided by 98 grams per mole gives us the total of 0.5837 moles per decimeter cube. And that will be our lesson. Hope that you have learned how to convert concentration from grams per decimeter cube to moles per decimeter cube, and understands the importance of expressing concentration in correct units.